Hello kids, it's your NOLA Mathman coming once again for another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound. I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
After watching this video, students will be able to evaluate transformations of quadratic graphs. The concept we're looking at is quadratic functions. The skill we're looking at is transformations of quadratic graphs. So with no further ado, let's get started with lesson 4.7. So in the first group of problems, we're writing each quadratic function in vertex form. We're going to identify the vertex, axis of symmetry, and direction of opening. We're going to start with problem number 4. Y equals -3 times x plus 5 squared. First thing you want to do is write the vertex form above the particular quadratic you're doing, which is a times x minus h squared plus k. By doing this vertex form, we can pull out the major components, which are a, h, and k. A is equal to -3, h is equal to -5, k is equal to 0. So as a result, the vertex is going to be in the form of hk. Since h and k are -5 and 0, our vertex point will be -5 and 0, as it shows up right here. So now we need to identify the axis of symmetry. The formula for the axis of symmetry we want to write every time we do this so we can get a habit of learning is going to be x equals h. It's a vertical line at the value of h. So in this case, it will be x equals -5, so you will have a vertical line at -5 if you were to graph that. So our axis of symmetry again is x equals -5. Direction of opening deals with a. A is -3. Since a is less than 0, it's negative. We know that it's going to be a graph that's going down. It's going to open down. And so that's going to show up here in a sec. A is less than 0. -3 is less than 0. So it opens down. And so we have now answered the 3 questions related to our problem. But again, you can only answer these questions in regards to the quadratic function when the problem is in vertex form, as we did. So we're done with our first one. Very good. Excellent job. We want to circle our answers. That's a good habit to use anytime we do these problems. So we've now done number 4. And so that's the problem. Now, the interesting thing about number 4, it was already in a sense in vertex form. So what happens when you have a problem that's not in vertex form, where the problem is more what we call standard form, ax squared plus bx plus c form? So let's see if we'll do a problem like that. Let's see what the NOLA Mathman does next. Oh yeah, we're doing number 6, which again looks like it's already in that form. So we're doing another problem that's quadratic form, as you can tell. And the reason you know it's in quadratic form, in vertex form, is because when you put that vertex form above the problem, you see that the format of the problem is the same format as the vertex form, as you can see above. That's why you always want to write the vertex form above whatever the quadratic function you get. And so like we did in the last problem, we will pull out a, h, and k, the major components that allows us to answer these questions. A is 1, h is 2, and k is -18. So since our vertex is in the form of hk, we know the vertex in this problem will be 2, -18. And so we write it and we circle the answer, letting us know that's our final answer. So our axis of symmetry, again, we write the general formula for that. And as we learned in the last problem, that formula will be a vertical line at h, which is x equals h. Since h is equal to 2, our axis of symmetry is x equals 2. So now for the direction of opening, we know that our a is 1. That is a positive number greater than 0. So we know that our parabola will open up and that will show up here in a second. 1 is greater than 0, and therefore the parabola opens up. And so, unlike the last problem where A was negative and it opened down, since this time A is positive, we know that the parabola will open up. And you can see the difference between when the values of A has one different sign from another sign, how that affects the direction of the opening. So we're done with that problem. Again, both problems 4 and 6 we've done thus far. The quadratic function has been presented in vertex form. So let's see if now the NOLA Mathman does a problem where it's a different form. So we got a new group of problems here. Problems 7 through 9 show up here on the whiteboard here. And so let's see what we do. Well, all 3 of these are in what we call standard form, so we will have to convert it into vertex form, so I'm excited. So we have here, we're doing number 7, y equals x squared minus 2x minus 5. And so the first thing we want to do again is write the vertex form of the problem, a times x minus h squared plus k. So again, to put it in vertex form, we have to complete the square. So we separate the negative 5. We take the 2 terms, x squared plus bx, which in this case is negative 2x, and we must create a quadratic perfect square trinomial so we can get a quadratic square. That third term will be in the form of b over 2 squared, as we learned in the concept of completing square. So we put that to the 2 terms. Next to the negative 5, we will subtract b over 2 squared, because since we added b over 2 squared, we have to subtract b over 2 squared on the right side of the negative 5 to counteract the one we added. So we do that. B in the problem is negative 2, so we substitute that into the formula b over 2 squared. We're left with x squared minus 2x plus negative 2 over 2 squared, which simplifies to negative 1 squared, minus 5 minus, because we have to subtract since we've added, negative 2 over 2 squared. That'll simplify to negative 1 squared. So again, we just do each step one at a time. Now we simplify negative 1 squared. Negative 1 times negative 1 is 1, so we have x squared minus 2x plus 1, minus 5 minus 1. So now we can write this as a binomial squared. It'll be x minus 1 squared. We simplify negative 1 and negative 5. That will give us negative 6. And now we have it in standard form. The NOLA Mathman shows that by putting the general form of the vertex form below our finished product. We're now able to pull out values a, h, and k. A is 1, h is equal to 1, and k is equal to negative 6. So since we know the vertex is in the form of hk, we know in this problem the vertex will be 1, negative 6. So now what we want to do is we have to now find our axis of symmetry, which will happen in a sec. We need to erase and create some space here for us to find the axis of symmetry. So while we're erasing, let's summarize what we've done. We've taken a problem in the basic quadratic form of ax squared plus bx plus c, and we converted it into vertex form. So again, we want to write our vertex form here so that we can use it to not only find the vertex, but to find the axis of symmetry also. So as indicated by the arrow, this is our vertex form for this particular problem. We will now find our axis of symmetry, which we know is a vertical line at h. So we will write the formula x equals h. H in this problem is what? Well, it's 1, and so our vertical line that will be our axis of symmetry is x equals 1. We circle that answer. Now we want to look for the direction of opening. Since a is equal to 1, we know a is greater than 0. It's a positive number. So the direction of opening, it has to open up, since it's a parabola that will be open upward since the a is positive. And so that will pop up here in a sec here. Opens up, and so now we have solved our problem and answered the 3 questions. We've got the vertex, we've gotten the axis of symmetry, and we found the direction of the opening. And so we're done with number 7. So this was a little different than the first two because, again, we took a problem that was in quadratic form, the basic general form ax squared plus bx plus c, converted it to vertex form so we can solve this problem. So let's see what we do next. Are we going to try number 9, a problem that's not in the form of x squared plus bx? Yes, that's what the NOLA Mathman decided to do. So this one's a little more interesting because we have a coefficient in front of x squared that is not 1. It's negative 3x squared plus 24x. So again, we write the general form in the vertex form above the problem. Y equals a times x minus h squared plus k. And again, the more you write it, the easier it is for you to retain and memorize it. So I always tell kids to do that. It makes it easy not only to pull out a, h, and k, but to learn the concept of vertex form. So in order to get our form so we can get our complete the square, we have to factor negative 3 out so we can get x squared by itself. So the first step is we factor negative 3 out of negative 3x squared plus 24x. We're left in a grouping symbol with x squared minus 8x. Now we're going to basically complete the square, and we're going to put plus b over 2 squared, which is our third term. Because we've added b over 2 squared, we must now, to the right of this, subtract b over 2 squared. So in our problem, b is equal to negative 8. We will substitute negative 8 for b into our equation, and we will complete the square and solve it. So we will write negative 3 times x squared minus 8x plus negative 8 over 2 squared. And then to the right of that, we will put minus negative 8 over 2 squared, as you can see there. And again, that's because we've created and added a term that wasn't there, and using the property of equality, we must subtract that term so that it'll be equivalent to the original problem. So now we simplify. Negative 8 over 2 is negative 4 squared. On the right side, we will subtract negative 4 squared. Negative 4 squared is equal to what? Well, we know that's negative 4 times negative 4, which is 16. We substitute that in, so we have negative 3 times x squared minus 8x plus 16 minus 16. So now we have a binomial square. We can go negative 3 times x minus 4 squared, which is basically b over 2, and we will put minus 16. Now we have it in what we call vertex form. So at this point, we write the general formula, or we compare it to the general formula we have above the problem at the top of the page, as you can see up there, and we pull out a, which is negative 3, we pull out h, which is 4, we pull out k, which is negative 16. At this point, we can now get the vertex, we can now get the axis of symmetry, and we can now find the direction to open. So our vertex obviously is in the form of hk. H is 4, so your point will be 4, negative 16. We circle that to let us know we got the answer. So now we're going to get the axis of symmetry. Like the last problem, we got to create some space. So we're going to erase some of our work that allowed us to get our vertex form. We're going to erase that work. And we'll keep the vertex form there because we need it in order to get the axis of symmetry in the direction of opening. So again, we erase that stuff, and we will now get our axis of symmetry. And now, as you know, what is the formula for our axis of symmetry? What's our general formula? Well, it's going to be x equals h, as we've done before. So we know that the axis of symmetry is a vertical line that splits the parabola into two mirror images, so to speak. And so in this problem, x is equal to 4 because h is equal to 4. And so now the direction of opening, our a is negative 3. Since negative 3 is less than 0, we know that this parabola has to open what? Up or down? Which one do you think? Well, we know it's going to open down, and so because a is negative. So we have completed this problem, And we're done with number 9. So we've done a variety of different problems, some that open up, some that's open down, some where the quadratic was already in vertex form, others where it wasn't in vertex form and we had to convert it. So we've done a variety of different problems that should get you more confident in this concept. So now we're going to get into graphing a function once we put it in vertex form. So we have a problem here, y equals negative 3x squared plus 4. So it's similar to the problem we just did, looks like. So we write our equation. Again, we want to put that equation in what we call vertex form. We write our vertex form above the problem. A times x minus h squared plus k. First thing we have to do is factor out negative 3 out of 3x squared. We will put x. Now what we do is move the 4 out because 4 is not a bx term, so we have to separate it and put it to the side. Since we know x squared is x minus 0, we really don't even have to complete the square. We just put x minus 0 because x minus 0 is x. And so we already have in vertex form now. So now we can pull out a, h, and k. A is negative 3, h is 0, k is equal to 4. And so since the vertex is in the form of hk, we know in this particular problem our vertex will be 0, 4. So now we need the axis symmetry, which we actually will use in this problem to graph, which you'll see the application of why you pull out this information for the purposes of graphing. So again, general form of axis symmetry is x is equal to h. Since h is equal to 0, our vertical line that's the axis symmetry is x equals 0. So we circle that because we're going to use it to graph in a few minutes. So now what we will do is we know since a is negative, it's going to open down. We don't necessarily have to write that. We're going to now start the process of graphing using the vertex and axis symmetry. So we draw axis symmetry, which is that dashed line at the y-axis. I label it AOS, that's the axis of symmetry. We graph our vertex point, which is 0 and 4. So we know that that vertex separates the graph into the left side of the axis of symmetry and the right. So we want to pick 2 x values to the left of the axis of symmetry and 2 to the right. And so we will pick negative 1 and negative 2 to the left of 0. We'll put positive 1 and 2 to the right of 0. And we're going to substitute those values of x to solve for y. And then we'll apply those points. So the first point we want to use is x equals 1. We substitute that into our vertex form. We'll have negative 3 times 1 minus 0 squared plus 4. 1 minus 0 is 1, so we'll have negative 3 times 1 squared plus 4. 1 squared is equal to 1, so we'll do negative 3 times 1 plus 4. And again, we want to use order of operation rules and do one step at a time, like we're doing. Next, we multiply negative 3 times 1. We run out of space, so I'll put an arrow there. Negative 3 times 1 is negative 3. Negative 3 plus 4 will give us a final y value of 1. So since negative 1 is 1 unit to the left, like 1 is 1 to the right, we know that that has to have the same y value. So we will put 1 for both negative 1 for x and 1 for x. They both have y values of 1. So now I'm going to pick one of the two values that we know will have the same y. X equals negative 2 or 2. We'll pick probably the positive number, which the NOLA MATHMAN does. And so we substitute 2 for 0 in our vertex form. So we rewrite it as negative 3 times 2 minus 0 squared plus 4. 2 minus 0 is what? We know that's 2. So we will have negative 3 times 2 squared plus 4. Now it's very important when you do this next step, follow order of operation. You do not multiply before you do exponents, so we must square 2 squared. That will give us negative 3 times 4 equals plus 4. Negative 3 times 4 is negative 12. Negative 12 plus 4 is negative 8. And so our y value when x is 2 will be negative 8. And when y is equal to negative, x is equal to negative 2, y is also negative 8. So we're at a point now where we can graph our points and be done with the problem. So we're first going to graph, let's see, what does the NOLA Mathman do? He does the positive values, so he does 1, 1, he does negative 1, 1, and then we're going to graph 2, negative 8, and graph negative 2, negative 8. And so those points will pop up. Since there's no negative, we kind of estimate the value of negative 8 since we only have 5 units down. And we now connect those points and create our parabola, which indicates the end of the problem because we have graphed this function correctly. So again, we have finished another math adventure. We've learned the concept of transformation of quadratic equations, and now we feel much more confident in this. And so until we meet again, the NOLA Mathman is signing off. Have a blessed and wonderful day. Bye-bye.